Hello and welcome to HP Gaming Garage. I am Professor Raja Ravichandra Prasad, Game Director at Artemisia College of Art and Design. The fifth module of game programming is integrating assets with animations in game engines. This process requires the use of various tools and techniques, including importing animations, working with animator controllers, animation clips, animator components, animation parameters, animation state transitions, blend trees and layers, playing animation through scripts and using animation events. To explain this in detail, I have Shriyams, an AS game developer, who will walk you through the module.
Thank you, Professor. Hello everyone, I am Shriyams and we will be discussing the module Integrating Assets with Animations in Game Engines, curated by Professor Raja. Integrating assets with animation in a game engine is a critical aspect of a game development. It involves bringing in 3D assets and animating them to create characters, environments and other interactive elements in the game. Let's begin with the first step of importing animations. Importing animations is a crucial step in game development that adds depth, realism and personality to game characters, environments and interactive elements. This process involves creating animations using 3D animation software such as Maya or Blender and exporting them in a compatible format such as FBX. However, before importing animations, it's crucial to ensure that the 3D models are being animated properly, prepared by rigging and optimized for real-time rendering in a game engine. These preparatory steps can save time and effort and result in a more seamless integration of animations into the game engine. Once the animations are imported, they can be previewed and edited in the game engine's animation editor. The animation editor provides a powerful set of tools to manipulate the animations, such as adjusting timing, modifying curves, and adding or removing keyframes. Previewing animations in the game engine allows developers to see how the animation will look in real time, interact with the game's physics, lighting and other elements, and ensure consistency with the game's overall aesthetic and style. Fine-tuning the animations in the animation editor ensures that they are suitable for the game's intended audience, genre, and tone, resulting in immersive and engaging gameplay experiences. Animator Controller is a crucial component that adds an extra layer of depth to animations in game development. It is a state machine that controls the flow of animations for a specific game object and provides a way to manage transitions between different animations. The Animator Controller is responsible for the smooth and seamless integration of animations into the game, making it an essential part of the development process. The Animator Controller is created using the game engine's animation editor. The process involves adding animation clips to the controller and defining the transitions between them. These transitions can be triggered by specific conditions such as player input or the state of the game world. This gives developers precise control over how animations are played back in the game and ensures that they are always in sync with the game's mechanics. Moreover, animator controllers can be used to add animation events which are used to trigger actions in the game. These events can be used to trigger sound effects, particle effects, or other actions that add to the game's overall immersion and player experience. By using animator controllers, developers can create complex, interactive animations that add an extra layer of depth to the game and make it feel more alive. The animation clip is a fundamental element of the animation process that game developers need to master to create stunning visual experiences. An animation clip is essentially a blueprint for a specific movement or action such as running, jumping, or attacking. It contains a set of keyframes that define the motion of a character or object over time. Creating these keyframes requires a high degree of skill and expertise in 3D animation. Once the animation clip is created, it can be imported into the game engine and added to the animator controller to be played back in the game. Fine-tuning animation clips is a critical step in the animation process. Game developers can use the game engine's animation editor to preview and edit the animation clips to ensure that they are suitable for the game. The animation clip can be looped or played only once depending on the requirements of the game. Looping the animation clip can create a seamless, natural motion that enhances the player's experience while playing it once, can create a more dramatic effect. By mastering animation clips, game developers can create visually stunning and engaging games that keep players coming back for more. Let's have a recap on what we discussed. Importing animations into a game engine requires the use of 3D animation software such as Maya or Blender and exporting in a compatible format like FBX. Proper preparation of 3D models is crucial to ensure they are rigged and optimized for real-time rendering in the game engine. The animations can be edited in the game engine's animation editor to ensure they fit in the game. An animator controller needs to be created after importing animations. The animator controller acts as a state machine that controls the animations for a particular game object. Transitions between different animations are created in the animator controller to control the flow of animations and trigger actions in the game such as sound effects or particle effects. Animation clips are collections of keyframes that define the movement of a character or object over time. They are created in 3D animation software and added to the animator controller to control the playback of animations. The animation clips can be previewed and edited in the game engine's animation editor. They represent a single animation such as walking, running, or jumping and can be looped or played once, depending on the requirements of the game. With animation parameters, the developer can control the behavior of the animator controller and create more engaging and interactive gameplay. These parameters can be triggered by user input or script events, allowing for seamless transitions between animations and more fine-tuned control over their playback. Not only can animation parameters be used to trigger transitions between different animation states, but they can be also used to adjust the speed of animations. This means that the developers can create animations that respond to the game's current state, making your game feel more alive and immersive. With the ability to control animation behavior and speed, one will have the power to create more dynamic and engaging gameplay experiences. Animation state transitions are an essential part of creating high-quality animations in game development. They allow for smooth and seamless movement from one animation to another, making the gameplay more immersive and engaging for players. When a transition is triggered, the animator controller will blend into two animation states together based on the transition settings. There are several transition settings that can be adjusted to control the blend between two animation states. These settings include the transition duration, the blending mode, and the conditions that need to be met for the transition to occur. By fine-tuning these settings, developers can create animation that seamlessly blend between states, creating a more immersive and engaging experience for players. Let's recap what we discussed. The animator component is added to the game object that needs animation playback control, such as starting, stopping, or transitioning between different animations. It references the animator controller and can be controlled by scripts or user input in the game. Animation parameters control the behavior of the animator controller, such as triggering transitions between different animation states or adjusting animation speed. They are defined in the animator controller and can be accessed and modified by scripts or user input. Animation state transitions define how the animator controller blends between two animation states, which can be triggered by animation parameters or the completion of an animation clip. The animator controller must have at least two animation states defined, and transitions can be adjusted by several settings such as transition duration, blending mode, and conditions for the transitions to occur. Let's move on to the next topic to discuss blend trees and layers. Blend trees and layers are powerful tools that allow game developers to create more complex and realistic animations. Blend trees allows for smooth transitions between different animations, making movements more fluid and lifelike. By blending animations based on parameters such as speed, direction, or input from the player, a blend tree can create more nuanced animations that respond to the player's actions. Layers are another tool that game developers can use to enhance animations. By adding additional animations on top of an existing animation, layers can create more complex movements and interactions. Animations can be played back through scripts using the animator component. This allows for a greater control over the playback of animations, such as triggering animations in response to the player input or events in the game. To play an animation through a script, the animator component needs to be referenced in the script. The animator component can then be used to set the parameters for the animation, such as the animation state, speed, and direction. Once the parameters are set, the animation that can be played by calling the appropriate functions. Playing animation through scripts is especially useful for creating dynamic and interactive gameplay. Animations can be triggered in response to player input such as jumping or attacking, or in response to events in the game such as opening a door or triggering an explosion. This allows for a more immersive and engaging gameplay experience. Let's have a recap on what we discussed. Blend trees are used for smooth transitions between different animations, while layers add additional animations on top of an existing animation. Animations can be played back through scripts using the animator component, which allows for greater control over the playback of animations. Playing animations through scripts is useful for creating dynamic and interactive gameplay. Let's move on to discuss the different types of animations in Unity. Rigid body animation is used to create pre-made animation sequences that move or change the properties of objects, considering those objects as whole or complete entities as opposed to objects with smaller and moving parts. Some examples of this type of animation are a car racing along a road, a door opening on its hinges, a spaceship flying through space on its trajectory, and a piano falling from a side of a building. These kinds of animations can be defined either directly in the Unity animation editor or inside 3D animation software such as Maya and then imported to Unity through mesh files. If a developer needs to animate human characters, animals, or exploding and deforming objects, then rigid body animation probably won't be enough. One will need bone-based animation, also called as rigged animation. This type of animation changes not the position, rotation, or scale of an object, but the movement and deformation of its internal parts across keyframes. Typically, bone-based animation is created as a complete animation sequence in 3D modeling software and is imported to Unity inside a mesh file, which can be processed and accessed via mechanism, the Unity animation system. In many cases, the developer can predefine the animation. That is, one can fully plan and create animation sequences for objects that will play in a predetermined way at runtime, such as walk cycles, sequences of the door opening, and others. But sometimes, the developer will need an animation that appears realistic and yet responds to its world dynamically based on decisions made by the player and other variable factors of the world that cannot be predicted ahead of time. There are different ways to handle these scenarios, but one is to use the Unity physics system, which includes components and other data that can be attached to objects to make them behave realistically. Examples of this includes falling to the ground under the effects of gravity and blending and twisting like cloth in the wind. Most animation methods considered so far are for clearly defined, tangible things in a scene, such as sprites and meshes. These are objects with clearly marked boundaries that can separate them from other things. But the developer will frequently need to animate less tangible, less solid, and less physical matter, such as smoke, fire, bubbles, sparkles, smog, swarms, fireworks, clouds, and others. For these purposes, a particle system is indispensable. Particle systems are entirely configurable objects that can be used to simulate rain, snow, a flock of birds, and more. Let's look at a recap what we discussed. Rigid body animation is used for creating animation sequences that move or change properties of objects as whole entities without affecting their internal components or forms. Bone-based animation is used for animating human characters and animals and deforming objects by manipulating the movement and deformation of their internal parts across keyframes. Sprite animation is used in 2D games, graphical user interfaces, and special effects to animate textures by playing a sequence of images or frames in order at a specified frame rate. Physics-based animation involves creating animation that responds to dynamic factors in the game world such as player decisions and variable environment conditions, often achieved through the use of the Unity physics system. Particle systems are used for animating intangible and non-solid elements such as smoke, fire, bubbles, and various visual effects. Particle systems are configurable objects that simulate natural phenomena or abstract visual elements.
Thank you, Shriyam, for the detailed walkthrough of the module. With this, we have come to the end of the module and I hope you enjoyed it. Stay tuned for your HP learning assessment so that you can be certified and start your career in game development. Thank you for joining us.